So we're going to talk about strings because it's a special class that's almost treated like a primitive type. And not only that, we're using this class like everywhere. We're going to use it for logs, we're going to use it for outputs. Even if you get into virtual reality, you'll need some sort of strings to either read some data, store some data, put some logs, etc. So it's important to understand how it works and to understand some of the pitfalls that normal programmers would get into on the early days of their life. So, what is a string? Well, there is no such thing as a primitive type called string. A string, which what allows us to do is to put a bunch of characters together, such as this example where we see R, E, Z, and A. To put them together, we're going to string them along, right? So this is where the word string comes from. So this stringing these characters together is actually saying we're going to have an array of characters that we're going to utilize. So a string underneath the hood is actually an array of characters. Well, string does a lot more than that. It's a helper class. It gives us ways to manage that array of characters. And this is what's important. Okay? Now, because we understand it's an array of characters, we also understand the limitations of an array. What that means is an array on a heap and stack location, when we create, let me actually go grab my pen here. When we create a variable, that variable is going to be on the stack, such as this S. And the moment we set the value of this S, it cannot be stored on the stack because it's not a primitive type. So we'll go on the heap, find a location that it could fit R, E, Z, A. And when it found that location, it's going to create a reference, an address, as the value of that S. So this S is going to reference this array of characters. And knowing that, we understand the limitation that could come with that. Okay, come with being a reference type variable. Okay, let's try this out in code. So if I wanted to do the same thing here, we would type in string S equals, let's say, res. And notice that it's probably the only type that where the compiler directly understands a specific value rather than saying new character array. Let's say if I had a character array C and we wanted to do the same thing, well, we had to initialize our array. Let's say R, E, Z, and A, right? Rather than doing this long process, we could just directly type it. And to be honest, string is going to contain this character array, right? If we want to, we could even hold down Control and go into the string class. Let me clear my screen a little bit. We could go into the string class and actually look how it's being implemented. And you could already see there is some, in this case, the values being stored as a byte array, right? And that's how it does it. And if you notice, it's final because all arrays, and this is an important thing to remember about our string, all arrays and all strings and anything this sort is immutable. And this is important. Immutable means it cannot mutate, right? The word mutation. What that means is it cannot change from the value that's been given to it. So this reza over here cannot get extended to rezas because there might be something there. So if we go one byte over, we might be into some memory of something else, either a different variable or application or whatever it is, doesn't matter. So if we ever change the value of reza, if we ever wanted to change the value of reza or the value of this character array, we need, as an example, before we do this, let's do the character array. We would need a new character array, which is going to be our temporary array. And we're going to set the size to that character array to be 1 or whatever amount we need more. A cool technique they utilize, we'll talk about this in the future, is to double the size of whatever it was. So because this creation is actually costly. But anyway, So here we had 4 characters, so we'll make it 8. So now we have enough space to store those values in there. So normally you would create like a for loop or whatever you want to copy those values. So let's say position equals 0. Position is less than c dot length, and then plus position, right? And then we would say temp at that position equals that c at position. So we copy all the values in there, right? So just to show it to you visually on the stack board over there, where's my pen? We created, actually we're gonna go from line to line. Line C6, we created an array called C. And it's referencing an array. So to be honest, it's the same as this. So we could just say this one, okay? To make our heap not look bigger than this. And then we created a variable called temp. And for temp, we said we need the size of characters times 8. So it goes, looks for that amount of space somewhere and finds it. So there's 8 stuff in there, okay? I don't know, I'm not counting. And this is going to have the address to that. Now in the next line over here, line 8 to 9, we say copy each one of those characters from C into temp. So line 9. So we copy R, E, Z, and A. And now we have space for 4 other characters. So now, if we want to, we could say, we're going to keep with temp for a second. We could say temp at position, let's say this is 0, 1, 2, 3. So at position 4 equals S as an example, right? And when we're done with all of this, we would make our C reference the same array that our temp is referencing. Temp, right? Now, this whole technique to copy, or sorry, to modify our C array, we had to do all of this. And all of this is done for us with our string. Whenever we create a new string, it will deal with it. Whenever we copy, adjust, add something to it, delete something, it would every time create a new string, copy everything to it, and then give it back to us, right? So even though it's immutable because it's an array, the class string takes care of managing the data inside, either adding, removing, whatever it is. And again, special class. And these are called helper classes. And we're going to see other helper classes soon. So knowing all this, if I wanted to add to my string, let me erase my screen a little bit. If I wanted to just add to my string, well, we could do plus equal something, and this would function correctly. Even though it's not adding directly to it, it's doing all the job required for it, such as creating a new string, adding ASD at the end, and then giving you back the new reference address, the new location of where this is stored. This is why it's so powerful. It does a lot of things. So let's talk about knowing that and knowing that this helper class helps us so much. Let's talk about a couple things we need to know about and issues that we could arise. So the first thing is we created a string. Let me go through my list. This string functions just like an array. So we get a length. So this would give us a value. Actually, there's a lot of methods that are useful for us. So we're just going to do s.length. We're going to put it in there. The same thing as an array, we could also get a specific position by typing character at what index we're talking about. So if I want 0, 1, 2, the Z, I have to say 2, right? Other methods that are going to be useful for us, I'm going to just type them out. You could test it out yourself. There is actually a lot, so you could go through this list and read them, right? You do a Control Q, and you're going to get a documentation, and that tells you everything you need to know, right? So let's say is empty is a good one. We just saw trim, which is a really good one. This removes leading and trailing spaces. You could also do that manually by saying s dot, let's say trail. Let's see, strip trailing. There we go. and s dot trail, no, rather than trail lead. There we go. Again, I don't try to memorize the terms. You just come back. The IntelliSense is going to autocomplete. Just kind of know what words we're looking for. This is all we need. And then the IntelliSense help us with everything else. Right? What else? So we have those. Something that's interesting. We could actually look into our array and look if a word is there. Such as, let's say, does it contain Reza? Or does it contain za, as an example? And we can print that out. Let's check it out. Right? And we're going to run that. So I'm getting a lot of warnings. You're not utilizing and you're not using it, etc. So you could see here, it's giving me true because it contains it. What if I said, does it contain Reza, the lowercase? And you're going to tell me right away, no, because I learned that uppercase and lowercase is not the same binary value. So this is not possible. So if I run this, you see it gives me false. But there's a lot of functionalities inside strings that could help us with this, such as one of those being we could make it all lowercase. Inside that lowercase, this is called the function trailing, or sorry, chaining. So method chaining. So here, the first part is we make it lowercase, and then the second part is we check if it contains it. Now, even though we changed the value to lowercase, we didn't change the value of s. This is creating a new reference to somewhere, and from that, we're checking the contains, and you can see it's giving us true. What I mean by that is if we check the value of s, we'll notice that it's still the capital R, right? So if I wanted to actually change the value, I'll either have to do s equals s2 lowercase as an example. Cool. The same way we could do lowercase, we could do uppercase, we could do anything like that. We could replace, you could check out those things. Now, let's talk about an issue that arises a lot with students. And that issue is when we're comparing our strings. So let's try this out. So here I have one string, and here I'm going to create another string. If we do it lowercase, this is pretty straightforward. I'm going to output it, and we're going to say s equal e. Is it the same thing? And you're going to tell me, well, no. One is lowercase, one is uppercase, so this is not true. So false. That's great. You did it good. What if I made both of them capital R's? And now you're going to do it, and you're going to say it's true because they're exactly the same thing. But this is a bad thing to do. Why? Because it's actually checking the reference of those things. It's checking the memory locations. So it's checking. Let me bring back my screen here. I'm going to just erase a little bit because there's too much stuff on my screen. Okay. Let me draw for 1 second. So again, we have our heap memory. And we have two values here. So normally, and pay attention here because this is something that we make mistakes. Okay, so we have our two character array and we have our stack. Now, what's interesting is when we create s, obviously it's going to find a location and it's going to create it, and this s is going to reference or have the address of this location. Now, when we create e, normally what we would think is it's going to go look for some location that's empty, and it's going to put those values and give you the reference to that. Well, actually, this might have been true before. It's not true anymore. This is because your compiler, there's a lot of programming in that compiler, and one of them is to optimize the code being given to them. So what it would do, this is something called interned. Okay, anyway, it doesn't matter. So what the compiler would do is it notices that the values are the same. So rather than giving you a new one, what it does, it kind of points to the same thing. Okay, we're not going to talk about too much of the details. So now when we're comparing here, again, these are the address we're comparing. These are the reference, let's say, the object itself, right? They're going to both be equal because they're both pointing to the same location. But this is wrong or fake or not true. And this could be problematic in the future. Where could it be problematic? Well, let's try something else. Just give me the mouse. So here, the two strings are actually the same value. What if I don't have a good example that would be valid, but what if it was actually RE, or actually let's erase this one, and here we're gonna say RE plus ZA, right? So we're going to add these two strings together and then we're going to compare. And again, let's make this all lowercase. And you're going to see it's again going to give us true, even though this is two strings separated, right? This is wrong. And you could see even there's giving a warning. Now, my examples are not the best. We'll talk about this in the future. But normally, when you want to compare strings, you don't want to compare the references. You want to compare the values. What you need to do is to say s dot equals, and then we could say, does it equal REZA? And we're getting a warning just to double check. Yeah, it's always true. That doesn't matter. But let's say if I had my variable that was there before, string e reza, and then over here we compare two strings. This is the correct way of doing it. Now I'm getting a warning because this is always going to be true because they both have the same values, blah, blah, blah. It's okay. But normally you would get these values from elsewhere, right? And even better is we could do s dot equals, but you could just say ignore the cases. And this is even, well, it depends what you're doing. But if you don't care about it being capital or lowercase and so forth, so on. Now, it's important that you utilize this equals. I am telling you, it's not the same thing as this. This is an important thing to see because this could eventually cause you some issues. If I find a good example, I'll come back and I'll make a quick video with our current level. So this is string. This is a helper class, and it's really important for us to note about its drawbacks, that about the stuff that it could do, and so forth, so on. One last thing I want to point out, is a string is an object. So one thing we could do is initialize it as null. So basically, it exists on the stack, but nowhere on the heap is it pointing to, right? And this could potentially give us null pointer errors and so forth, so on. So be careful about that. In this case, the equals is okay. What if I did s equal e? That could probably give us our null pointer issue. No. Again, the compiler is helping us out. This is pretty much all I wanted to talk about. Thanks, guys. See you in the next video.